Good afternoon, sir. Shall we start the session? Good afternoon, sir. Shall we start the session?
Yes, I'm available.
Okay, sir. Thank you.
This is Chetan Raikar. I'm available.
Yes, sir. Thank you. Thank you.
Hi. Can you see the screen properly?
Yes, sir. So, very good afternoon. I am Professor S.P. Chavan. On behalf of G.K. Guzar Memorial Charitable Trust, Dr. Ashok Guzar Technical Institutes, Dr. Daludrao Aher College of Engineering, Karad from Satara district welcomes to the Day 2, Session 4 of ATAL FDP on Industry Academia, Synergy in Disaster Management and Resilient Infrastructure for Advancing Sustainable Development. So it is my privilege to introduce our distinguished resource person, Engineer Chetan Raikar, sir, a nationally and internationally respected expert in the field of structural engineering, repairs, and heritage conservation. Mr. Raikar is the chairman of Structwel Designers and Consultant Private Limited, a 58-year-old multidisciplinary consultancy with a strong legacy in structural design, repair and restoration, health assessment of structures, and material testing. He also heads the R&D division of Structwel and holds 2 patents in the material testing, reflecting his strong orientation towards applied research and innovation. Academically, he holds a bachelor degree in civil engineering from Sardar Patel University, Gujarat, and master's degree in conservation of heritage structures from Heriot Pratt University, Edinburgh, UK. His professional expertise spans health assessment of concrete structures, non-destructive testing, repairs and retrofitting, concrete technology, and conservation of heritage structures. He is also an accredited mediator certified by the Indian Institute of Arbitrators and Mediators. Mr. Raikar has led over 1,000 projects involving collapse investigation, structural audits, and restoration work across commercial, institutional, healthcare, industrial buildings, bridges, metros, airports, dams, refineries, and marine structures. His notable contributions include landmark heritage projects such as Chhatrapati Shivaji Maharaj Terminus, a UNESCO World Heritage Site, Gateway of India, Taj Palace Hotel, Haji Ali Dargah, Watson Hotel, Rajwada Indore, Falaknuma Palace, and Bagmati. He has played a key role in the conservation of more than 100 historic structures and has been instrumental in applying advanced non-destructive testing techniques such as infrared thermography, radar, petrography, and endoscopy in complex structures. An active contributor to academia and professional bodies, Mr. Raikar has authored over 200 technical papers, delivered more than 200 lectures in India and abroad, and regularly serve as a speaker on health assessment and heritage conservation. He is a visiting faculty at Engineering and Architectural Institution and a faculty member for MSBT faculty development programs. His professional affiliation include Fellow of the Institution of Engineers, past president of the American Concrete Institute India chapter, and membership in several national as well as international engineering and heritage organizations.
आता लक्षात आलं.
In recognition
चेतन
of
रायकर सर आहेत ना?
In
चेतन पाटील
recognition
सरांचे
of
best
his outstanding contributions,
चेतन रायकर सर.
he has received over 20 national
चेतन
and
रायकर म्हणून आहे.
international awards.
Retrofitting.
Beyond his professional achievements, Mr. Raikar actively contributes to society as a trustee of Saath Trust, supporting children with thalassemia, and Saisha Foundation, promoting nation building through music. Ladies and gentlemen, we are truly honored to have with us a professional whose work seamlessly bridges engineering excellence, heritage conservation, research, and social responsibility. So once again, I welcome to Engineer Raikar sir and participants and all participants. So I request Raikar sir, please take a charge. Thank you, sir.
Sir, probably you'll have to unmute yourself.
Are you? Namaskar, everyone. Are you able to hear me?
Yes, sir, very clearly.
Very nice. So I'll try and share my presentation. I have about 90 minutes, isn't it? The presentation is for about 90 minutes, 1.5
Yes,
hours.
sir. Yes,
है ना?
sir.
So I can finish maybe 5-7 minutes earlier so that we can have some
No
question
worries.
answers. है ना?
Yes,
We
sir.
can do
Yes.
that. Let me try and share. I'm not very good at IT, so
No worries. We'll help you, sir. No worries.
no. I'm in my office, so my team can
Yeah,
probably help
certainly.
me. Are
Yes,
you
sir.
are you able to see the screen?
Yes,
Yes,
sir.
sir.
Can I make this full screen now? One second, I'm trying to make it. Yeah, is this full screen now for you better?
Yes, sir.
Yeah. So let me try and start. So the topic that was given to me was advanced methodologies for structural integrity assessment and performance evaluation. है ना? So when this topic was given to me, in fact, let me first pay my homage to Dr. Kumthekar sir, a very dear friend of mine who started this FDP and said you have to talk on this subject. So we lost him quite prematurely, and a very, very good friend of mine I lost, So it's my homage to him before we start any kind of presentation. And I'm sure he's there with us in the spirit, if not in person today. And let me remember him and start. So when I was thinking about this subject, the first thing that came to my mind is integrity. What is integrity? We talk of integrity of human beings. When we say, oh, this person has integrity, that means he does not have, say, corruption or corrupt practices, or has a good moral conduct, and so many aspects. So now, what do we mean by integrity? Is the definition of integrity is the state of being united or undivided. Now, when we are talking of a structure being united or undivided, can see each a structure has about 70, 80, 100 odd components. We talk of RCC, bricks, plaster, waterproofing, about 10 components that are related to structural engineering. Balance 60, 70 components of electrical, mechanical, plumbing, air conditioning, firefighting, so many aspects in a building, furniture. We have kitchen appliances, kitchen platforms, so many architectural finishes we have. So, can the structure be in a state that is united or undivided? It's very difficult. Like when a human being dies, what happens actually? It is the heart which stops, which is called clinical death. But when the heart stops, are the other body parts functioning? Yes, they are functioning. The kidney can function. The eyes are also. People donate eyes, people donate kidneys, people donate so many other organs after death also. So those organs are still usable. So not that all the components of a body or all the organs of a body die at the same time. Clinical death is when the heart stops. Similarly, what could be the clinical death of a structure? Does it have to collapse fully, or does it have to tilt to the extent that it is not capable of, it is not serving the purpose that it is designed for? If it is a residential building and if it tilts fully, then what happens? We are not able to use it. It's still safe, but we are not able to use it. So it is clinically dead, we can call it. So my definition of structural integrity is when a structure is capable of offering services for which it was built, like if it's a residential building, if it serves residential purpose, if it is commercial, if it serves commercial purposes, that means it's capable of taking different levels of live loads. If it's a bridge, then different level of rolling loads, because the difference between a bridge and any other type of structure is the bridge has rolling load. Other structures have stationary load, more or less, Then if it's an industrial structure, it can take crane, it can take so many other impact loading, vibrations and things like that. So structural integrity is where a structure is capable of serving you. Is that a definition that appears to be complete to you? At the end of my presentation, we can discuss more on this. So, how to assess structural integrity? Now, my subject is advanced techniques. So if I am going to talk on advanced technique, there are some basic techniques also. That means no for so we define structural integrity as a state of the structure in which all the components of a structure are working together. The reinforcement, the concrete, the beams, columns, slabs, chachas, foundations, whether it's piles or open foundations, it's all working together to resist the kind of live load that we're talking of, external loads, wind, earthquake, cyclone, and so many other aspects. So how do we assess structural integrity? There are so many non-destructive testing equipments available. There are about 15, 16 or 20 of them we have. There are many more. There are about 10 more that is available in the market, or maybe even slightly more. I don't claim that I know everything, but there may be at least 10 more. So how do we assess a structure? Or when we use non-destructive testing, what do we actually measure? Yeah, what do we actually measure when we use any non-destructive testing? We actually measure properties of the material that have gone into structure. If it is a steel structure, then the properties of structure, the strain that is there on structure, the strain that is there on the beam, the column. The beam or column can be wooden, can be cast iron, can be steel, can be concrete, can be brick masonry. So the material of construction of the structure can be different, but the measurement of strain technique can remain the same because strain is change in dimension upon original dimension. So we will talk more about this in later part of my presentation. What is performance evaluation? When we say performance evaluation, what do we expect? What performance do we expect from the structure? We expect that the structure will be, first and foremost thing is safe. Second is it will not leak, it will not bend, it will not give undue vibrations. See, if the structure gives undue vibrations, you are also scared of using the structure. So it should be psychologically also safe. The structure has to show a level of rigidity, not that it just collapses every time. If it vibrates too much, and safe of a structure will mean other parameters also. Structural integrity is where we actually check whether the structure will collapse suddenly or in due course, and whereas performance evaluation we measure other aspects, as I said, cracking. If the cracking is um, dead or live cracking. Is there dead or live cracking? Yes. A crack that does not uh, see, if my shirt tears accidentally, it is torn shirt, but it is torn accidentally. So that torn portion will not keep extending. But if the shirt has worn out, it will keep tearing again and again and again. If it's a very old shirt, if the thread strength has gone, if the stitch strength has gone, my shirt will keep tearing again and again and again. Exactly similar thing. If the structure is overloaded because of a single instance, it can develop a cracking that may be a dead crack or a dormant crack, uh, uh, which may not keep growing, which may not keep extending. But if the structure has age-related damage, that is corrosion damage or stress that is exceeding the load carrying capacity of an individual structural member, then the crack can keep propagating. That can be called as a live crack or an active crack. So that's the difference between a live crack and an or a dead crack, what I call it, or dormant crack. Structural integrity means structural design, factor of safety, construction techniques, their shortcomings, original construction deficiencies, maintenance challenges, and maintainable structures. So let us try and understand. In integrity, we are required to consider all these aspects. Whether the original structural design, let's go to the first part, original structural design. Whether the original structural design was safe. Was it safe on paper? And was it safe on ground? If the construction quality is poor, but the structural design was just the right, then the structure was safe on paper. It is safe on ground during the initial ages of the structure, initial few years, but the structure will deteriorate much faster because the original construction quality is not all that good. So the structure will deteriorate fast. And though the structure is safe in structural design and on paper, it may become unsafe very soon, early stage of service life. We see so many bridges collapse in 1 year, 2 years, 5 years. So many structures collapse in 4 years, 5 years, less than 5 years, and even during construction. So when we have to assess the structural integrity, first and foremost thing is that we must assess is whether the structural design is safe. Now, when we go to a structure that is 30, 40, 50, 100 years old, and then we are asked to check the structural integrity, I'll be covering a few case studies on that. So you, you will start asking why, how do we, when I don't have the structural designs, I don't have the structural drawings. So how do I check whether the structural design and drawings, the structural design as originally designed is safe? How do we do that? So first and foremost thing is you need to prepare structural drawings of the structure. And when I say structural drawings, it is an extension of architectural drawings. First and foremost thing is you try and identify whether the structure is RCC or load bearing. If it is load bearing, then a different level of architectural structural drawing is required to be provided. If it is RCC, a different level of structural design drawing. Now, if it comes to RCC, then the question is whether it is pre-stressed or a normal RCC structure. Another component, another angle is whether it's a precast or a normal cast in situ kind of a construction. So these variations will decide to what level you need to provide the RCC, you need to provide the structural, need to prepare the structural drawing, because in most cases, 99 out of 100 cases, you will not have the structural design and drawings available when you take up a project for assessing the structural integrity. Next point is the factor of safety. Once we have designed the structure, once we have prepared the structural drawings, the immediate next question that would come to me was, sir, how do we assess the reinforcement? There are equipment available, cover meter, magnetometer, or profometer, or whatever is the trade name or the technical name. They all help us in getting the quantum of reinforcement that is provided in the RCC members. There is a huge limitation on the RCC, the reinforcement detection. The bar diameter, there is a huge limitation. It's a limitation of technology. It's not the limitation of any equipment. We have about 3 or 4 different types of profometers. All of them have more or less a severe level of inaccuracy, which is not acceptable as a structural engineer in me. Like suppose if the bar is 16 dia and the machine says it is 18 dia, then now how do I know whether it is 20 or 16 You understand my point? So the equipment, there is a limitation in use of cover meter. Now, second limitation is if there is a second layer of reinforcement in a beam bottom, sometimes you provide reinforcement in 2 layers, 3 layers, 4 layers also, depending if it's a very big girder, I-shaped RCC girder and things like that, you may have 4 layers. It does have a limitation in identifying 4 layers. Third limitation the technique has is if the reinforcement is very close to each other, then the instrument is unable to detect the number of bars also. If there are bundled bars, the equipment completely conks off. So now, in that case, how do we assess the factor of safety? It's a big challenge because factor of safety is there in the grade of material also, like the grade of masonry. Now, how do you assess the grade of masonry? It will depend on the mortar proportion and it would depend on the type of material used. If it's stone, whether it's brick. Today we have concrete blocks. So what is the strength of the concrete blocks? It is not available today. If it's a solid block, you can still take a few cores and do compression testing and find out the strength of the block. But if it's a hollow block, then it is practically impossible to know the strength of a block which is already gone into the structure and which is there for 30-40 years. So if it's a hollow block masonry and you are expected to do work out the factor of safety of a hollow block masonry structure which is load bearing, then it's a good enough challenge. You will require some amount of approximation, some amount of experience that you gain from the confidence that you gain from experience. It cannot be. So structural integrity assessment is not a bookish material at all. It is not a bookish technique at all. You have to have a huge level of, as I said, the structural design. You must know structural designers, so you must have a structural designer into the team. Second is material technologists into the team. So arrive at factor of safety, material is first, and second is the level of structural design. Suppose if Indian standard says it requires X number of bars and you have provided X.01. So many designers do it very in Marathi, what we call it cartoon kutun design, cut to cut design, just the right kind of. In that case, the factor of safety is eaten up very fast in the service life of the structure. So you need an experienced person to arrive at what exactly is the factor of safety. You can see so many structures which are not designed well, but they survive for 20 years, 30 years, 40 years because the quality of construction is good. So many structures which are structurally good, but not well constructed, they still survive 2, 3, 4, 5 years, 10 years, 20 years, 25 years. But if the structure is marginally structurally designed and poorly constructed, it barely goes service life of even 2 decades, double digit age, that's I'm talking of more than 10 years. So second aspect is to work out the factor of safety. To know the construction techniques, we just talked about a few construction techniques like hollow block load bearing masonry, solid block load bearing masonry, stone load bearing masonry, bricks load bearing masonry. You can have Ceporex blocks, what we call AAC, autoclaved air cured blocks. That is another level of load bearing. Now, when it comes to RCC, we also saw normal plain RCC, precast pre-stressed. So many techniques of constructions are prevalent in last 40, 50, 60 years. Before that, 100 years back, it was predominantly load-bearing structure. So it had a different challenge. Today, load-bearing structures, none of us, I'm saying us because I believe major part of the audience today who is listening to this lecture is faculty. So we really do not teach load bearing in a very great detail in the engineering colleges. The kind of stress that we give on RCC structures, we also have concrete as a 100-mark subject, but we do not give that much of emphasis on load bearing structures, which I feel we should, because if we are able to teach load bearing structures, we can easily go back to load bearing structures which are economically more sustainable, but that's not the topic of my discussions today. We will talk on it some other time, and the longevity of those structures is a lot more. Shortcomings, what are the shortcomings? I also said if it is a hollow block load-bearing masonry structure, then it's a shortcoming that you are not able to know the compressive strength of the hollow blocks used. Original construction deficiencies, if the construction techniques have not been followed well, or if it's a wrong technique that has been used originally, then we call it OCDs, original construction deficiencies. Those have to be clearly identified in working out the integrity of the structure. The maintenance challenges and maintainable structures. What are the maintainable maintenance challenges that have the maintenance team uh, seen in maintaining a structure today? Unfortunately, very, very, very few. Try and understand. I use the word very thrice because I'm in the field of maintenance of structures and I know how poorly the structures are constructed as far as the maintainability is concerned. Constructed, I will go back to the designed on drawing board. No architect, no structural engineer is aware about maintenance and maintainability of different components of a structure. They give a duct which is only 1.5 foot by 2 feet and has 6 pipes in it. How does one replace the pipe? How does even go inside? And then they put RCC grill outside, which is a permanent feature. So no one can get into the thing. So if the pipeline starts leaking, you have to even break the RCC grill and only then maintain it. Second aspect is things that go above the false ceiling. You really do not understand, and suddenly the false ceiling comes down someday along with the bottom plaster, the bottom concrete, below the cover concrete, below the reinforcement, and it's on. So people have to, in engineering colleges, we will have to teach them maintenance and maintainable structures. I think that is being covered in most of the diploma colleges because there is 100 marks subject of repairs and maintenance in all the diploma colleges across Maharashtra. I'm not too sure whether we have it in degree colleges also. If not, this subject must be started very soon because it's a huge, huge, huge requirement of maintenance engineers in construction engineering. One second, yeah. Factors affecting the structural integrity. First factor that affects the structural integrity is poor design. It's a poor architectural design or a poor structural design or poor services design. When I say poor architectural design, uh, light and ventilation is not properly designed in a building. Most of the buildings or the flats that are constructed in Mumbai today are open only on one side, in one direction. There are a few flats which are open on two sides. Very, very, very few flats that are open on three sides. And practically no flats that are open on all the four sides. Even if there is a single flat on the floor, on one side it has lifts, it has staircase. So the best flat that is available in Mumbai is open on three sides. But most, I do not know the number, but I can just throw a number, say maybe 70-80% flats are open on one side. Out of the balance, 20-25% are open on two sides, and very, very few open on uh, three sides. That's poor architectural design. Waterproofing is not designed properly. In structural design, we have floating columns that are accepted, hidden beams that are accepted. These are all problems in structural design. In services design, plumbing is not designed by a plumbing engineer. It is designed by the plumber directly on site. He cuts beams, he makes holes in beams, cuts the bars and shifts the bars, shifts the pipeline the way he wants. So services design also is a big challenge. Poor detailing. Inadequate and incorrect detailing. Try and understand. Inadequate is something that is not sufficient enough. And incorrect is completely wrong. Today, the waterproofing on the terrace and on the chajjas is designed by architects. And let me make a little blunt statement that architects are not capable of designing waterproofing. In my career of 39 years, I have not seen a single architectural company giving waterproofing drawings. It is left to the site engineer's experience and left to the kadia, the mason who designs the waterproofing. And the architect, the only condition that he puts is, I do not want any rainwater downtake pipes in the frontage, and no pipe should be seen in the elevation. It's a big challenge for the waterproofing designers. So that's then the whole thing ends up into incorrect detailing, and the structure leaks lifelong because it's a poorly constructed structure. Poor specifications, lack of knowledge of materials. Today we really do not know. If I ask a question, what is the purpose of brick bat coba in waterproofing? I'm not too sure how many of the listeners are able to answer this question. We are all training the youngsters. What is the purpose of, what is IPS as a material? We don't know. How do you design waterproofing of a chacha? We do not know. Bricks. Do we get good bricks? Are the bricks that are available good enough for brick masonry? We don't know. Blocks. We really have very poor knowledge of material behavior. At best, what we know about bricks is the absorption and the compressive strength, or any block masonry for that matter. We really do not know about the heat component of it, the fire part of it, fire resistance, heat resistance, and so many other things. And use of unproven materials. Every few years, there is a material that few months, a new material comes in the market without doing proper or adequate R&D, and it is sold off in the market to be used in construction. A most efficient structure will be when all the components die at the same time. You understand? I'll repeat the statement. A most efficient structure would be when all the components die at the same time. But same thing should be in the human body also. If God wanted, he would have stopped all the components at the same time, from eyes to ears to tongue to throat to heart to brain to everything would have stopped at the same time. Even God is not able to do it. So even we are not able to do it. As engineers, as structural engineers, as civil engineers, as architects, we are unable to do it. So when we are using a new material, we must understand what is its life. If the life of that new material is 5 years or 10 years, and the life of a structure is considered as 50 years or 60 years, so you need to replace this new material every 5 years or 10 years. So 5 times in the service life of, so how do you replace? What is the kind of inconvenience that is going to be? See, today we use different types of marble, different types of new marbles that are available. And that marble cracks because it is not strong enough. We use different types of tiles. They crack. The tiles are very fancy, very expensive, but they are not of a standard quality. So the tiles crack. We use different types. Originate goes to the Y flat in less than 30 seconds or 60 seconds. So the person staying in Y flat does not understand where is the fire coming from, because it's not originate from his or her flat, and he really doesn't know in which direction to run because he sees fire everywhere suddenly. So there are so many things. I can go on and on and on. So use of unproven materials also is a factor that is affecting the structural integrity. Poor construction, poor quality, pilferage and corruption. Unfortunately, whatever our Honorable Prime Minister says, the corruption levels in construction industry have to improve a lot yet. Maybe the generation next of civil engineering will see a corruption-free construction industry or a very limited corruption in construction industry. Today it is still rampant. The quality of the roads, the quality of bridges, the quality of other public services is far from desired, far from its very early stage of its service life. These structures, that is roads, bridges, they require from resurfacing to reconstruction. Anything. I have seen both kinds of damage and quite a few in number. It's not that, oh, very, very only 1% of the bridges are good, you know. There is, I'm yet to see a bridge that is trouble free for 20 years or 25 years. Best quality construction in Mumbai today, 50 storied, 70 storied, starts crumbling in less than 10 years. Corporate developers, good names, still. Pilferage is again a challenge. Today, everyone wants to be rich. Why not? We all want to be rich and famous. But corruption is not the way. Pilferage, म्हणजे चोरी करणे is not the way. That's not the way to get rich and famous. But some people do that. We'll have to. So those of you who are into consultancy and also teaching, which is a very good thing. I always believe every professor must be into consultancy also. So please be very clear and careful about what is happening on your sites when you are giving structural consultancy, whether there is any pilferage. After you have checked the reinforcement, whether the contractor takes out a few bars and sells them in scrap. Poor maintenance. Ignorance is one. Lack of knowledge of maintenance is second. Inaccessibility. We discussed about ducts, terrace, sloping roofs. Many a times sloping roofs do not have an access. So how does the maintenance engineer go up? It does not have the sloping roof does not have a parapet wall around. So how does if the person goes up, he's worried about his health, his safety. So sloping roofs is again a inaccessible part. Above the false ceiling and restricted area. There are many cases the areas are restricted. In a hospital, ICU is a restricted area. Not everybody can go. So we have to be careful in these areas, and the construction have to have better maintainable designs and designs which require lesser maintenance in restricted areas or in sloping roofs or in ducts, terraces, and above the false ceiling, all of it. And the factors that affect structural integrity, I think this is the last point in this slide, is natural, flood, earthquake. Natural aspects that affect the structural integrity is the flood, earthquake, cyclone, or man-made aspects have fire, blast, accident, or structural modifications. Structural modifications also is very rampant in Mumbai. There have been a few collapses which are caused by the interior changes done by an individual. Tampering with the columns of a multi-storied building. Multi-storied, when I say it's 5, 7, 7-storied also is also multi-story building. In that case, the interior designer, just he wants to slice off the column by an inch and a half. He doesn't realize that the column is already structurally not very safe, just marginally designed, poorly constructed, and you slice off some component of it. He says, "अरे sir, मैंने तो 1 इंच काटा था, 1 इंच नहीं काटना है." But it happens in Mumbai, and the structures come down, killing a few people. I've been part of the investigation committees of collapsed structures. Some of these are due to the last aspect, structural modifications. Now, when we are talking of integrity or health of a structure, what do we mean by health of a structure? Someone who coined this term very intelligently compared structure to a human being. See, when we are talking of health of a structure, it has to be in the complete state of safety and serviceability. We just saw it. I spoke about this when we were talking of integrity some time back. Why do we need structural health monitoring? Like after a certain age, doctor says की आता दर वर्षाला जा आणि टेस्टिंग करून घ्या तुमच्या शक्ती, तुमच्या शरीराचं, तुमच्या हृदयाचं, तुमच्या इतर कॉम्पोनंट्स बॉडीच्या. Let us talk of the heart, which causes or does not cause death. As I said, clinical death is only when heart stops, not the brain stops. There are brain dead people who go in coma, who are there for years together. There are people without eyes, without hands, without all the components, without teeth, but not without heart. Even with kidneys, you can go for dialysis and keep living longer. What affects the heart? Cholesterol. We all know about it. So cholesterol, I am comparing it to increase in load or depletion of strength. In a structure, when the load increases or the strength of the structure decreases, it is growth of cholesterol. See, when cholesterol grows in the arteries, the blood arteries, it clogs the arteries. What happens is the blood pressure goes up. So increase of load or depletion of strength will increase the stress level. In human body, it's a blood pressure that increases, and in structure, the increase in stress level. Then we get heart attacks, first heart attack, second heart attack, third heart attack. The equivalent to that, I am saying, is cracking, buckling, or bending of the structure. The slabs starts sagging, but we don't consider that as a challenge. In many cases, even structural engineers do not understand the cracking in beams, the cracking in columns. They are not able to identify what is a bad crack or a dangerous crack. So cracking, buckling, and bending in beams, steel structures, is I compare it to heart attack 1, 2, or 3. Then next is cardiac arrest, when a person dies, or the collapse is the next stage. There are few other aspects where a person can be murdered, a healthy person can be murdered, which I compared to unauthorized modifications. We just saw. If you make unauthorized structural modifications, you are as good as murdering the structure. Even if the structure stays for a few years after that, it is not. No RCC component or a structural component in a building should be modified without carrying out detailed 3D structural analysis is the golden rule. And if you follow that, you would not want to make structural changes anytime in the service life of the structure. And there is one more possibility, that is slow poisoning, which is neglected maintenance. Like we take bath every day. We brush our teeth twice a day, thrice a day. Some people do it only once, but twice a day. Is that not maintenance? So why do we say that structures do not need maintenance? World's best machine, a Rolls-Royce, also needs maintenance. We saw what happened when the flights do not receive proper maintenance. It causes a havoc, kills so many people in one single accident. Our car, it requires maintenance. We send it for servicing, we send it for clutch plate fixing, brakes, this, that, whatever. So if we neglect our structures, it is as good as slow poisoning our structures. So when to do structural health monitoring? All this is for integrity assessment, assessing the integrity of a structure. We can do it before a calamity, that is a regular audit, age related. Corporation says that after 30 years, you do it once in 5 years or something of that sort. After 15 years, once in 5 years, and after 30 years, once in 3 years. Why 5 years and 3 years? And why 15 years and 30 years? From where has this golden rule come? Doctor says, आता तुम्ही 60 वर्षाचे झालात ना, आता दरवर्षी तुम्ही टेस्टिंग करा. But there are people dying at 38 and 42. Should they wait till 60? No. So coming back to the point, age-related damage and regular audit need not have a frequency. That's the frequency, the furthest that the government has said. You should be careful about your structure. You can go for more frequent audits than what the statutory bodies specify. Special audit. change of use. Suppose a residential building you want to change into a library or a commercial building, then you need to do special audits. Or after a calamity like earthquake, flood, cyclone, or blast, or fire. These are the steps that we have. First, when we go to the site, we go for data collection, then visual inspection, then non-destructive testing. Data collection is whether we have RCC drawings, whether we have architectural drawings, whether we have MEP drawings, that is, plumbing, electrical drawings, firefighting drawings, and things like that. That is the data collection. What is the age of the structure? What has been the usage? What is the current usage? Are there any changes made? So many things that go in data collection. Visual inspection, inspect the entire building through a trained visual inspector. Non-destructive testing, somebody else must have spoken more about it. I'll go a little faster. Defect evaluation, that is identifying the defects that we have seen from non-destructive testing and visual inspection and list them down. Then give a remedy to each, give a solution to each defect. Then specifications and costing for working out the costing of repairs. Then tendering and contractor, execution of repairs, and certification of structural integrity or structural stability, and handing over. These are the steps. Data collection, we saw architectural listing, maintenance records, history of use, type of loading, type of problems, cracking, leakage, vibrations. Go to visual inspection. Visual inspection has no substitute. Only a trained and expert person must do visual inspection. Access system. At all, or any other structure for that matter, how do you have the access system? So access is a major challenge. Are you able to hear me? Because this is showing me some internet instability. Are you able to hear me? Identification of level of distress. That is the next that we do in visual inspection. Various types of distresses. We saw that NDT program, preparation of distress mapping. Let us go for tools that we use in inspection. Hammer, digital camera, binocular, endoscope. We'll see more about endoscope, infrared, and drones. These are the different types of accesses. You can have a Jula. These are engineering Julas. Or you can have absolutely a MBIU, that is mobile bridge inspection units. Then from visual inspections, you can actually see the kind of and the level of distresses. You can see the fire damage structure, corrosion damage structures on the top, or partially collapsed structure, and concrete, which is chemically affected, in a chemical plant. Endoscope. Endoscope is a tool that is used by medical science predominantly. We also are using an endoscope for almost 25 years. Wherever a human eye cannot go, an endoscope goes and you see inside. Like doctor puts the endoscope through the mouth or other orifices of the body and tries to find out what is inside. तो तोंडातनं ट्यूब घालतात दुर्बिणीतून नसबंदी is what exactly that durbin is called endoscope. So he will put the endoscope through the mouth and say, oh, तुमच्या गळ्यात ट्यूमर झालेला आहे, or a cancer झालेला आहे, तुम्हाला काय झालेलं आहे? Cancer means, of course, that he can detect after putting it for the testing. But he knows there is a tumor, or he knows you have boils inside, or अरे तुमचा घसा भाजला आहे, काही गरम प्यायला होतात का? All these things. So that is endoscope. Similarly, you see these three. This photograph, he's putting an endoscope above the false ceiling. He has just removed a light fixture, put the endoscope up, and he is inspecting the complete RCC slab that is above the false ceiling. You cannot inspect a slab above a false ceiling without either removing the false ceiling or putting an endoscope up. Removing a false ceiling is very expensive. It's not required. So you can use an endoscope. That is first type. Second type is cracks inside a load-bearing masonry wall. That is so there are cracks. The joints have opened out, and we really want to know to what depth the joints have opened out. What is the weakness inside? So you can put an endoscope here. And the third is RCC component that are holes, there are holes in it. So you are checking whether there is a corrosion and things like that inside. So endoscopes can be used for so many cracks and crevices and other usages. See, this is how the endoscope can be seen. You can send an endoscope inside a cored hole also, and you can check for knowing what is inside. This is again endoscopy that is used for knowing the condition of the buried ends of steel or wooden joists. This is how the endoscope looks. Let me go a little faster. So endoscope these are all endoscopic photographs. So these three, the top middle, top left and bottom left are good wood, and the top right and bottom mid are the holes that you see with an endoscope. So endoscope is nothing but an eye that goes inside the structure with a light source. So it's a very simple technique. This is how it looks in a steel, corroded steel. Top three and the bottom is a core. We have taken photographs inside a core. IR camera. IR camera, it's infrared, so it works on the principle of temperature difference. So if you have a temperature difference, this is the photograph. This is the person who is holding an IR camera and taking a photograph of this. What you see here is what is shown and manifested in an IR camera, because this is where the horizontal bamboo that had gone inside, it was removed. This hole was not filled up properly, but in and plastered. So in plastering, everything looks good, but this is typically a problematic area, and which can lead to leakage in service life. So IR camera can use for this. IR camera can be used on chimneys, because accessing a chimney is very difficult. You can take photographs using an IR camera to identify voids or hollows in tall structures, in dead walls of structure where access is a big challenge. Today you can use drones or IR cameras to go closer to the structure without climbing to that height. This is how a chimney can be inspected from outside. This is how you can inspect the top surface of a terrace also using an IR camera to know the debonding. You wash the whole terrace, allow it to settle down in 10 minutes, let it dry out and take IR cameras photos. You will know the hollows because the water will go inside, and the temperature difference will give you different areas what you see on the right hand side. This is how the photographs of top portion of a terrace can be seen with an IR camera. Second is drones. We all use drones. Drones have been in use in India for almost 20 years in marriages and so many common functions. So drones is not a novelty. Excellent tool to be used for underside of the bridges or tall structures. These are the various things. This is, it's available on the net also. Let me not waste your time. All these are the standards which can be the organizers can circulate it with all the faculty members and they can use them. The challenges in non-destructive testing is the access inspection underwater. See, most rivers in India that I have come across have got a very turbid water. So it is not possible to inspect. Even if you take good quality photographs, you don't see anything. So inspection underwater, particularly for bridges, is a major challenge in inspections. Non-availability of technical data. As I said, the RCC drawings are absolutely not available, and the limitations on NDT testing in occupied structures. Let me go a little faster on this. These are a few techniques that are being shown, but I'm sure somebody else is talking in greater depth on the basic NDT techniques. I will go for more advanced NDT techniques. On what you see on the right hand side is the core. We take a core cylinder and send it for compression, chemical analysis, RCPT, and so many other tests. What you see on the left hand side is the half cell potentiometer, which is measuring the probability of corrosion. These are the different inspection techniques. This is where one is doing the ultrasonic on both sides. You can see Smith hammer on this, and this is ultrasonic direct texting, coring. This is where the inspection and testing being done simultaneously. It is quite a risky location because this is open sea. This is open sea bridge, and where my inspection, but then they are having the safety harnesses, they are having safety belts and going down on a jula and carrying out. This is the Smith hammer and this is ultrasonic. Cover meter and magnetometer, half cell potentiometer, coring, chemical analysis, carbonation. These are all very basic and simple tests. RCPT is again RCPT and water permeability are laboratory tests. These tests are very, very good when the concrete is beyond the basic challenges of voids and permeability, voids and honeycombing. When we go for secondary challenges of concrete, that is permeability, that is whether it is air permeability or water permeability, that's where these tests are very useful. When you are dealing with high strength concretes, these tests are a lot more useful. If you are using M15, M20 and you have got honeycombing and voids, then these tests are not good for you, so it's limpet, that is pull off test. So this test can give you uh, the bond strength of two layers, compressive strength of concrete also, bond strength of plaster also, bond strength of tiles. It's a very good technique. It is easily available. More on this is available on the net. So I'll just give you an indication or information of the technique. Limpet pull-off test is a very good technique, very accurate and good for qualitative or comparative assessment also. This is how limpet test is carried out. Petrography is another very good tool that gives you about the DNA of concrete, the DNA of the material, the DNA of the stone that is used. When I say DNA, it is not the DNA that is exactly same, but we know from which quarry the stone has come, what are the micro defects in concrete, and how to overcome those micro defects. See, in so many cases, you see some kind of a chemical coating being done on marble temples and this and that. It's not required because the particle size of the chemical coating is more than the pore size of the marble. So the chemical coating will remain only on surface and it will weather out in no time. So why are you spending your money on something that's not going to last for 10 years, 15 years? It will last for only a year or max 2 years. Of course, if you have got more money, you go ahead. But then these techniques, that is petrography on concrete, petrography on stones, are very, very useful in identifying the micro defects in concrete and stones. So this is what we are doing. We are doing, one of the case studies is we are doing Hajeli Dargah in Mumbai, or other marble structures that we use. We go for petrography identification in a big way, because we want to use Hajeli Dargah is in the middle of sea. So we must have a marble that has got least air and water absorption. So we selected Makrana marble after doing petrography of almost 40 different types of marble. Now every lot that comes to site, we do petrography to check whether what has come on site is genuinely from Makrana or it's a mix-up. So petrography is a very useful test when we are using either a stone or a concrete of higher strength, where you want to say petrography is useful in fire damaged assessment also, whether the concrete has micro cracks which cannot be seen by a naked eye. Petrography can give you those details and data. This is how the micrographs look. This is typically the alkali aggregate reaction ring that is seen in this thing. I'll talk more about it in some other lecture of mine. Structural health monitoring, that's where you are measuring the strain. We all know that strain is delta L upon L or delta B upon B. There is change in dimension upon original dimension. So when there is a stress, there is a strain. Stress is proportional to strain within elastic limits. That's Hooke's law, I think. No? You professors know more about the theory than we practicing professionals do. But so if we know the original strain in a structure, we are able to measure the change in strain. From change in strain, you can know change in stress and whether the structure is safe or getting into the unsafe limits. All this, that is structural health monitoring can be very easily, very effectively done using strain gauge monitoring. You can do temperature monitoring in raft concretes, mass concretes, when you want to control the temperature to whatever 28 degrees, 30 degrees, 32 degrees, or whatever is the prescribed limit. You can actually use temperature gauges. That is called health monitoring of structures. And now I simply made a statement. When you know the original strain, how do you know the original strain? That is the challenge. We do not know. Arey, pani gere. We do not know what is the original strain in a structure unless you de-strain or de-stress the structure, which is not possible because any structure will have minimum dead load. So that is what you can work out for the grade of concrete or for the grade of steel from the dead weight. If you are able to remove the complete live load, you can actually know the strain that is due to the live load or a dead load, and also the residual strain. Even after the live load goes, there will always be a residual strain. So it's not as easy as I am putting it across. It does require a good level of combination between a structural engineer and a material scientist. But this is a very good tool in doing health assessment of a structure in situ. This is where you check the deflections and deformations in a structure. A load testing being done in a bridge. It's a metro bridge. It's an old slide. You can use total stations to know the deflections in beams or other deformations. Case study 1. I have about 20 minutes. So case study 1, earthquake affected palace, that is Wagh Mandir. Now we are talking of integrity. I will show you a few slides where the confidence of a structural engineer will shatter. Of course, this is a very old photograph, 110 years old photograph. It's a beautiful structure in Morvi, Gujarat. I am covering, I think, 4 or 5 case studies, very, very short, 5, 10 slides of each. This is where earthquake affected structure. This is how the structure was when I went to the site for the first time. You can see the crown stone here. The crown stone. The top of this is supposed to be here. Sorry, here. And this has moved by about 8 inches. If this collapses, the whole arch will collapse. There were about 500 crown stones like this. This is the worst, but about 500 crown stones with different degree of displacement, vertical displacement because of an earthquake. Can you see here, this is standing without a crown stone. So this challenges or defies the structural science, the science of structural engineering, that how can an arch stand without a crown stone? Here, this is standing without a crown stone. Here, the crown stone is about to collapse. So virtually, the compression action, semicircular compression action of the arch is missing, and still the arch is standing. Still, the whole structure is standing. But it can't stand for long. One more earthquake, and it would have collapsed. So one aspect was, see, you can see the level of cracking. This is all as good as 6 inches of cracking in the this thing. This is the shikhar of Wagh Mandir. You can see the level of movement in the stone. This is about 4 to 5 inches. This stone, this gap is about 4 to 5 inches. The stone has moved. So one thing is you remove all this, but then second thing is, can we push? Just pick this up a bit and push this stone back. This is what we have done, and that is where it saves the cost. Similar thing we did for the crown stones also. Of course, we did the movement by man and machine both, cranes and chain pulley blocks also. Now let us see how we shifted this crown stone back. in its original place. This has moved by about a couple of centimeters. What I saw, the worst was about 20 centimeters, but this is about a couple of centimeters. So how do you push it back? So the simple technique we used was using a truck jack, because a truck jack can easily take a load of 2 tons, 3 tons, 4 tons. And this ground stone, the highest weight was 450 kilos or 500, 600 kilos. Now I don't remember. But so using a truck jack, we pushed every stone back to its original position. So in the process, we propped two sides where needed, pushed the stone back, and then see, this is how the simple manual technique by unskilled laborer. Go slowly, point by point, point by point, one turn, check, one turn, check. So you turn the jack once and check. Yes, stone is going in the right direction. There is a person who is moving the stone at the top. This person is moving the stone, and this person is turning the jack. So they are in coordination, and someone is inspecting. So our first few slides, we stood, even I stood, and first few crown stones, we pushed them back personally. Then it became like a system. So we almost had 500 crown stones pushed back into their position in a very limited cost. And that is what is engineering restoration is all about. To do the structure, just the right kind of repairs is what is needed. Then we put the steel pins. This is how we put the steel pins across 2 stones or 3 stones. So the crown stone was placed back in position and held back in position for the next earthquake. This we completed about 14-15 years back, and it is still standing with all the earthquakes that the structure has faced. So what we have done probably seems to be working. That's the next technique we used for structural integrity. You can see the level of cracks. This is a 450 thick masonry, and you can see the see-through cracks. So this structure is so badly moved. So now how do you do integrity of this? So what we did was, this is a 2-story cross section. We drilled holes of 50 diameter from the top to the plinth. This is where the plinth is about 1.8. That's about 6 feet of plinth in major portion, because this is a palace and it had a higher plinth. So we drilled holes of 50 dia, that is only this 2 inches diameter, through holes right from the terrace down to the plinth. That was close to 12 meters little plus. Inserted a steel rod and then grouted. See, this is how, using a simple coring technique we used. See, you can see this is the ground level, this is the terrace level, and this is how we were removing part by part, stone by stone. Drilled a 50 diameter core, put a reinforcement. This is where the reinforcement is being inserted, and this is where the concrete. So we created a concrete. This is poured concrete, with 10 downsize. So we created a 15 diameter reinforced concrete pillar from top to bottom of the reinforcement, every 1.5 meters, or at every T junction of the load bearing wall. So we vertically breast the entire structure with steel, without the steel being seen anywhere, because this is a heritage structure. So we do not want the steel to be seen. Like today, I am wearing spectacles. If I don't want to wear spectacles, what is the option? Either I improve my strength of the eye by doing yoga or all those techniques, or I use a lens. If I use a lens, no one will know that I'm wearing specs or I'm wearing lens. So we did something similar to that here. So this is another 5 feet long, extra long drills we had, and we drilled horizontally also, and connected 3 stones using stainless steel or mild steel pins, and grouted that annular space. So these are the techniques of structurally reinforcement the structure in the vertical direction and in the horizontal direction. This is improving the structural integrity. You can see a couple of slides before and after. This is the same slide. This portion was pushed back, and this is what recreated. This whole thing had collapsed. So we restored the entire dome, or the cupola, what we call, reconstructed that. This is how it is. This is how the structure looks. Case study 2 is conservation of Rajwada in Indore. Indore Rajwada also was a 7-story structure. Fire damage. This is the palace structure or Darbar Hall structure. We had stone columns originally, but we did not go for stone columns for cost and time reasons, because these columns had lime rendering, that is lime plastering. So why go for columns? It's not needed, you know. So we went for concrete columns instead of stone columns. You can see the concrete columns here. Here on this we put a stone cap, and on that we had a steel column. So if you see, in a single component we have RCC column up to here, then this much part is a stone column and this is a steel column again, and then you have steel beams cladded on both sides with stone beams. So externally you see a stone beam with a steel beam inside. Externally you see stone, but there is a steel column inside, and you have a concrete column. So this is a classic case of 3 different materials used in single height of 18 feet column. So this is how it is. You know, what you see here is a RCC, then it's a stone. You have a steel uh, circular column in between, and then you have, see, this is where you can see the steel column in which this cap is woven inside like this. It goes inside, you know. So and on the top again you have a steel column. Can you see it here? You have structural steel beams, and then the RCC slab was created. A perfect technique of 3 different materials blending in unison, and this is how the completed structure looks. Case study 3 is fire damage Keshavarao Bhosle Natyagruha in Kolhapur. This is a grade 1 heritage building. Fire damage recently, about a year and about 15 months back. This is how the separation because of fire, you know, the load bearing walls are separated because of fire. Everyone said, let's demolish the structure because it is very badly damaged. But we took up the challenge of restoring rather than demolishing. This load bearing masonry wall was completely strengthened using grouting technique and steel plate fleaching technique. 2 techniques we use is a random rubble masonry, and it is only a ground story structure. But this is how it is. It's under construction. It's nearing the restoration part is nearing completion now. These are balcony beams where the would be created. It's under recreation, and this is where the structure is. Next is Taj Mahal, which I'll go very fast because I've seen this. I've shown this case study in a few presentations earlier. This is how the dome was. This is how during construction, and this is how the completed dome looks. Here also we use the techniques of pressure grouting inside the load-bearing masonry walls to make them strong. In process of pointing, you need to put mastic tapes. This is what the slide shows, because if you do not put the mastic tapes, the masonry starts looking very ugly. A few construction strengthening techniques. One is fiber wrap. Fiber wrap is your unidirectionally aligned or 2 directionally aligned carbon or glass fibers being glued to concrete or any other member. You can do fiber wrapping to masonry also. You can do fiber wrapping to wood also. You can do fiber wrapping to concrete also, and strengthen it for taking additional load. This technique is good. It does have its limitations, so it has to be used with a pinch of salt. Steel plate fleaching. We can also use steel plates instead of fiber wrap. Steel plate is a more assured technique, but more clumsy. Fiber wrap is simpler, faster. Both are equally effective, I would say, but steel plate fleaching has more assurance. in the minds of structural engineer. You can do strengthening of footings also. This is jacketing being done to a footing. If you want to increase the load carrying capacity of a column, how do you strengthen the footing? See, this is where, I'm sorry, why is it going on its own? See, this is the original footing and this is the extended footing. So you are increasing the plan area. This is the original and this is the extended footing. So you are increasing the plan area, increasing the thickness also, and footing is being. So now you may say, how are you, what are you doing about the reinforcement? So you can actually provide horizontal drills and put more reinforcement, or put eye girders also across, make a combination of grillage come open. So it all depends on the kind of technique that you want to use in foundation strength. And this is where the jacketing to a column is. Jacketing is nothing but adding extra concrete around a beam, around around the column. Of course, you can do jacketing to beams also, but it's mostly done because jacketing is good in compression members. Jacketing, because beams are predominantly flexural members, and if you do jacketing to the concrete below neutral axis, how much effective it is or how much needed it is something that can be debated. This is we are talking substitute structural framework system. So wherein if you have to strengthen a slab, see, everyone knows WL square by 8 is the bending moment formula, different 8, 12, whatever. So if you go for WL square by 8, W is the load. If you cannot reduce the load, reduce the span. If you divide the span to half, so L by 2. So what will happen is WL square, if your span is reduced to half, 4 will go in the denomination. So it will become WL square by 32, 8 चौका 32. You understand? I'm talking very in a very simple formula and giving a very simple. So if you reduce the span by half, the bending moment will come to 1/4 straight away. If you reduce the span to 1/3, it will go to 1/9, and so on. So if you have to strengthen a slab and you cannot use any strengthening techniques, you can easily reduce the span of the slab or a beam for that matter. If you are able to put additional beam, you can. Only thing is you have to be careful about is you are changing the load transfer path in a building. If a primary beam is being made secondary beam, then you have to be sure of where you are transferring the load, on which columns. Are there columns which are taking new and additional load now, and are they capable of doing? That's what you have to think. Same way with the slabs also. If you're transferring the slab load onto beams, if you divide the slab half, there is a possibility that you are making a one-way slab into a two-way slab. So load on some other beams is increasing, and are these beams capable of taking that additional load is what you need to see. This is typically what a jacketing column photo looks like. This is the, in the middle photograph, this is the original size. This is the new size with new reinforcement. So this is the industrial structure where they wanted to put additional load of industrial reactors, and that's why the whole system had to be, I think, 4 or 5 storied structure, which was completely, all the external columns and internal columns were jacketed and strengthened. And you may say, why did you not reconstruct? Two things. One is uh, repairs is cost effective also and time effective also. It's a lot faster to repair a structure in most cases than replace a structure, because replacement requires a lot of statutory clearances also, whereas repairs requires very, very few statutory clearances in most cases. So repairing is a lot faster and is a lot more economical also. So when we are talking of structural integrity, these are the few techniques that we use, and I think that was my last slide. So this is, we have a few minutes of question answers if that is permitted. Thank you very much.
Thank you, sir. Any question from participants? Yes, please. Any question from participant? Yes, please.
Hey, mute, unmute. Yeah. Hello.
Yeah.
Myself, architect Manorama Patil, sir.
Yes, ma'am.
First of all, thank you for a very beautiful, I would say, stimulating, engaging, and informative lecture.
Thank you, ma'am.
Which was a blend of ground realities, practical aspects, which kept us engaging, connecting with the truly whatever the title of that today's session is, like truly blending industry and academia. So, especially 2 to 3 days, we have been all engineers coming, but today we as architect were participant also in your slides. So it was good, like, and it was very informative, and means I could not resist to thank you, sir, for such a wonderful session.
Thank you.
Really,
Thank you,
really
ma'am.
helpful and wonderful, and particularly the analogies which you gave while explaining, making it more simplified. Whatever that heavy topic of structural analysis and all those things, giving the analogies of human body, that was the best part, which I liked particularly. So we could imbibe all that heavy topic. Was very good. That's what we say, cherry on the top for all the
Thank you.
thing. Thank you very
Thank
much, sir.
you.
Thank you very
My
much.
pleasure. My pleasure.
Yeah,
Thank you.
yeah, yeah.
Good afternoon, sir. I am Dr.
Yes.
Rajendra Koli, architect from Pune.
Yes.
And
Yes.
really, I inspired by your fruitful lecture about repair, replacement, and maintenance. And
Thank
duly
you.
it gave a enlightenment to the all architects, those who are practicing also, teaching also, like myself.
Thank you.
And
Thank you.
just I have one question that in Indore
Yeah.
Palace, you have used three materials for
Correct.
restoration.
Correct.
That is also MS1, then stone, and then marble. Then how the
Yes.
behavior of these materials when they unitely they will work together in the
Correct.
coming years?
Correct. Correct. That is what is required to be calculated. See, like, uh, if I can explain it a little greater, the
Yeah.
original slab. This is a 250 now 275-year-old palace. So it's an archaeological structure. Original slab of this was in vaulted brick, but the vaulted brick were above a false ceiling. So it actually didn't matter whether we replaced it with any other material. That is point number one. So if the question is from the archaeological point of view, anything about the false ceiling, if it is not changing the aesthetics, I can easily change the material. So we rebuilt it in concrete. Now question number two, Indore is a drier climate area. If this palace was in Mumbai, my thought process would have been different because Indore has very slow process of corrosion. Mumbai or any other coastal area has very high process of corrosion. Plus Mumbai has a lot of pollution also. So rate of corrosion is very fast in Mumbai. So I
Yes.
was not hesitant to use a steel since the structure was in Mumbai. Tomorrow if the structure is in Nagpur, I won't hesitate to use steel. So
Yeah.
coming back to the point when we have three different materials, it was a sandstone, not marble. So concrete, a sandstone in between, and a steel
RCC.
column above. Now RCC at the bottom, sandstone in the middle, and steel column above. You have to be very careful about the structural connections of the three. So for that, you have to understand how each material performs. That's why I spoke on 2 3 occasions in my entire presentation. You require a structural engineer also and a material scientist also in it. You must understand what are the strain adjustments in the three materials and how. See, steel and concrete, they
Yes.
behave very well, but stone component and concrete, they have to blend together. Stone and steel, they are completely different materials. So because of, but the stone size of the stone was so rigid, I would say it was one stone member inside the steel pipe, and then that steel pipe was welded to the column above. That's how the whole structural integrity was assured.
Yes, thank you, sir.
My pleasure.
Anybody? So I sincerely thank our today's esteemed resource person, Engineer Chetan Raikar sir, for sharing his valuable time for discussion on the subject of advanced methodology for structural integrity assessment and performance evaluation. Sir has very nicely correlated the human body with building structure, means failure of human body and how the failure of structure. There is one very heart-touching slide, sir. That is blood pressure. Increasing blood pressure means what actually happened in construction, in every structure. Heart attack means cardiac arrest means murder, slow poisoning. So this is very wonderful slide, sir, as per
Thank you.
my opinion.
Thank
Then
you.
how to assess structural integrity, how we have to focus on material and level up standard during the structural integrity discussion. Then uh, in some case studies, sir, you are also present it very nicely. Also, what are the factors affecting on structural integrity? What are the challenges of waterproofing? In conclusion, that advanced methodology for structural integrity assessment and performance evaluation is robust, innovative, and forward-looking. It offers significant potential to improve structural safety as well as life of structure. So once again, thank you, sir, and thank you all participants for patience listening. So
Thank you. Thank you
here
very
I
much.
conclude that session is over, sir. Okay, thank you.
So can I exit?
Yes, sir. Sure.
Thank you. Bye bye. See you, everybody. Thank you. Thank you very much.
Okay.